In this video, I'm going to introduce you about the equation of plane. The equation of plane means that equation of plane is a three-dimension geometry. So which, for example, if I have a paper, right, this paper is a linear, right, it's linear. So where if I'm moving this direction, right, it will have a normal. They will have a normal to the plane, right? They have a normal. So once I changing the direction, they have different name for the plane. Alright, means that the plane can have different, it's the same plane, but as long when I tilt the plane, the normal, the direction of the plane will be different. Right? If you're going this way, the normal will going this way. If you're going this way, the normal will facing this way. If I'm going this way, the normal will facing this way. For a same plane, they will have different equation of plane. It's because of the normal of the plane. The normal of the plane is very important in deciding the equation of plane. So now I will tell you that, so this plane, let's say this is a plane, so and we have a normal vector, right? We have a normal vector. I'm going to derive the equation of the plane. Okay, then again I have a fixed point, right? A is a known point or the fixed point, right? It's a fixed point. It's not a variable point. Means that we know what is a point. And there is another line. And there is another point, which is a variable point or a moving point. This point must be on the plane, right? Anywhere on the plane. So if I drawing the, if I finding the direction, right? The direction of this point, fixed point, to the variable point, right? This point. So it's anywhere, all right, around the plane. So because this is on the plane, all right, it's on the plane. So it's on the plane, right? It's on the plane. It's on the plane. So there is a normal here, right? There is a normal here. Any line on the plane, either this line, or any line on the plane is always perpendicular to the normal of the plane, right? So means that this is the direction of the normal and this is the direction of the line on the plane. And I can say that the line AR, the direction line AR, dot with the normal vector, what do you think? What is the result, right? Okay, you have to understand the concept of dot product. So this line, this normal is perpendicular to the plane. And any line along the plane, on the plane, is always perpendicular to this normal. So when they are perpendicular, when two vectors are perpendicular to each other, the dot product, you will getting 0. This is a very important result from the dot product, right? So as I can rewrite AR, right? AR to be, okay, this is actually a position vector, right? There is a position vector R. So means from O to A, O to R, and O to A. So this is A, right? I just write OA to be position vector, and OR is a position vector. I can rewrite it as R, right? So, and AR is actually OR minus with OA. And dot with N equals to 0, right? And I can rewrite O to R as a R and OA as A. So if you dot with N, you are getting 0. Right, now I'm going to do some expansion. So the dot product of R dot N, A dot N, minus with A dot N, you are getting 0. So the formula for A dot N is the same as moving the other side, it will get negative. It will be positive A dot N. This will be the formula of equation of plane, right? This will be the formula for the equation of plane. So for line, for a straight line, it will be R equals to A plus TV. And for equation of plane will be R dot N equals to A dot N. What's the difference between a plane and a line? All right, a plane, a line, right? A straight line. A straight line, you need a fixed point and you need a direction. As long as you have a direction, have a fixed point, you can getting the equation of line, right? But for a plane, you need a normal. You need the normal, and you need a fixed point, right? Any point on the plane, all right? So that you can apply this formula. All right, let's see in the next video how to apply this formula to finding the equation of plane.